Hello everyone, this is a tutorial for 2GAX 2021 fall. And in this tutorial, I'm going to cover a very simple Unity tutorial for beginners, yeah. And after this tutorial, you will be able to aggregate a flocking element as such in a very pretty simple way of achieving this. And I'm going to share with you how to do this. And you can actually, after this, you can pause them and save it and export them into any other third-party softwares. And I imported them as OBJ into Rhino, and you can actually use them as actual mesh objects, and you can play with the geometries. Okay, so let's begin the tutorial. So firstly, you should install Unity. Unity is free. So this is a Unity hub. If you download Unity, it's going to ask you to install from here. After you install this Unity hub, you will be able to install a lot of different Unity versions under here. What you will need for now is Unity version 2020.3 point something something. So the latest long-term support release. So these are the official release. I am today using 19.4 something. Yeah, but you should use, I'm recommending you to use this one. And if on the date you're watching this tutorial, if you have a latest LTS version, you install that one. Do not install anything else as pre-release, or you don't need to use any other later version like this. Okay, so once you have your version installed, also, if you don't see like all these small components, you don't have to worry too much. You can always come back here and add modules, and you can click and unclick any of these things to add different modules and basically extra plugins. So what you will need is this Microsoft Visual Studio Community. You want to tick that. You don't really need this at the moment, but you will need Universal Windows and Windows build support, maybe documentation, yeah. These are the ones that I ticked. So if you want to just follow my instruction, you can also do that. Okay, so once you have that installed, you won't see anything here if you're new. These are like, you will have a lot of different programs. Basically, that's your project, yeah. And you can, if you want to open a previously built project, you can use open, but if you don't have anything, we are going to create a new project. So once you click that, there are lots of templates here. We are going to use 3D sample scene HDRP. So this, all of these are good to use. It's just different templates. So they're all similar, very, very similar. But HDRP and URP-RP is a render pipeline, provides us a better rendering quality. And we don't have to set anything. So we are going to click on this one, HDRP. And I'm going to save it on my desktop. And I'm going to change the project name to Complex Morphologies. And say create. And it's going to take a while, a little bit, yeah. And it's going to create a folder here. So that is your project. So after you build this project, work on it, you close Unity, you can move this anywhere for convenience, and you can also share this folder with your teammates and so on. Okay, now the Unity got opened with HDRP render pipeline setup, and we can just ignore it. And that's a file with a sample scene here. So what we can see here is there is an inspector window, a hierarchy window here, a project folder, controller, game scene, and all these windows with scene window, package manager, asset store, and animator. And if you don't see these windows, don't worry, you can go to Windows and General and find out the actual scene that you need. If you happen to have different kinds of vision, that's okay. All right, so here in the scene, we can have a look. So what we got here is a main camera. This is the camera. So the camera is the position that actually what you will see actually in your built game. So this is the lens through the window that you are going to see if you build a game. And there is this directional light. You can move the lighting direction. And the position of this light doesn't change, doesn't make any difference. So the direction is the most important here. And the sky and fog volume and all these are from the template. If you open a non-template file, you won't see any of this. So these are just the scene. We can actually just turn it off, for example. And live prop group, this one, we can also, it's associated with the geometry, so we can turn this off. Post process volume, this is making your scene look nicer. So we can keep this. And sky and fog volume, this is also like giving a little bit of foggy background, so you can see whatever you need, like according to your need. So we are going to keep this too. And if the icon is too big or too disturbing, you can turn this off, or you can turn the icon size smaller or bigger. So that's about those elements in the scene. And if you see this star, because we made some changes, it's asking you, it's warning you that you need to save it. So if I click Control S, now it's saving. Okay. And I can use pressing Alt and use mouse left, middle, and right mouse button. So you can rotate, zoom, and pan around. We use Alt key, same as Maya. Okay, and if you go to console, if you see any warning, warning is kind of okay. It means like it's a warning, but it won't error. But if you see any red warning, that means it's erroring. Your folder or your software is not going to run. So if you happen to see any red warning for no reason, please see what the error message is and try to fix it, maybe by Googling the word. The yellow warning is okay. But for example, I had some issue with the 2020 installation. When I installed it, it just gave me some like few red errors for no reason. So I decided not to use that version. So maybe if that also happens to you, try to use earlier official release version. Yeah, see if that fixes your problem. So yeah, there are some certain things that are very difficult to tell. Okay. So the exercise we are going to do today is very specific. So I'm not going to cover too much of the basics, but if you are interested in knowing more, I have a lot of basic tutorials, basic to intermediate to advanced tutorials about Unity, different examples on my YouTube channel. And yeah, if you need more basic tutorials, there are so many online tutorials out there. I myself learned from YouTube searching. So yeah, go ahead and do that. So this one, I'm going to go directly to the to that specific example. Okay, so the assets folder. This folder corresponds to my actual folder that is just created on my desktop. So I can see that I have an assets folder under here, and the folders here are corresponding. So in the future, we are going to add and drag a lot of files and create a lot of files here, and they will appear here. For example, we will add a lot of scripts under here, and you will bring your obj model that you modeled from external software. You are going to drag them here. Okay. So I'm going to share a folder with you with these 4 different scripts. So we are going to import that to your scripts folder. You can create a new folder, but I'm going to just use scripts folder as you already have it there. So right click and create a folder, and I'm going to name it Boids. Boids is a name of an algorithm. So if you go to Google and Google Boids, it explains the background of that. Yeah, and you can see why this person created this Boids. It's a algorithm to for computer compute and visualize the bird flocking or crowd behavior. Like so, it's like kind of invented by this person, and the name is for birds and droid. Like Android is robot, so it's Boids, bird and robot. So it's a very efficient way of simulating crowd behavior. It also considers different neighbor relationships. You will not code everything here, but it's actually very good to learn how to just like code this from scratch. So I have tutorials on YouTube channel showing literally how to code this from scratch. So yeah, and not only me, there are lots of other tutorials about how to code this from scratch. But I have tutorials how to code this from scratch in Unity. So if you're interested in, I encourage you to watch it if you are interested in developing your scripting skills. So we are today we are just going to just use the ready-made script. So you can drag this, drag 4 scripts here. That's it. And that's inside your script folder. Okay. So it's called Boids and Boids script. And what I'm going to do, I'm going to actually right click and create an empty object. Oh, by the way, in Unity, you can create a lot of different objects by right click, or you can go to game object and add different, for example, cube and everything. So we can check. So we are going to make a cube first, just to understand what this is. Okay. So we have a cube object. All right, and it's created in zeros in weird position. You can right click and say reset, or you type 000 to kind of snap this to a 000 position. So you see this kind of weird thing. This is coming from the HDRP, creates some lighting reflection information for automatically. So don't worry about it. If you are not in HDRP template, you won't see this. So yeah, don't worry about these dots. Just ignore it. You can actually turn off the gizmo. And okay, this object, I'm going to use this to actually check my world size, because I'm going to make a lot of flocking geometries, right? I'm going to make around few hundreds of them flocking around and creating their own clusters in 3-dimensional world. And it's important that I understand where they are generated, so I know and I can control the scale. So I'm going to make this inside this 10 by 10 by 10 world. And now we know that this is 0, 0, 0 position. And if you see the colored gizmo here, X, Z, Y is colored right there, right? So it means this area, do you see this grid? So let me write. So this grid is positive. So from here, because this is 0, and this one grid is actually 1 unit. So this is 10 grid and 10 units. So this means I'm at 0, 1, 2, 3, 4, 5, 6, and so on, and vice versa. So just watch where the colors are indicating. That is the positive side, and where they're gray, they are negative side. Let me close this. Okay. In the reason I'm explaining this, because in our script, it generates initial population on the positive side, from 0 to the positive side of your selected parameter. So basically, I'm going to create my world. The size of my world will be 10 by 10 by 10. Yeah. And if I use this specific script, it's going to use 10 by 10 by 10 at the positive side. So I'm going to, it's equivalent to, I move this box by 2, 5, 5, 5, which means that I snap the bottom left corner to 0, 0, 0 position. Okay. So I created this cube just to explain you where this geometry is going to get generated. So just in order to have this as a reference, I'm going to give a color, transparent color. just so we can see what's happening after we use the script. All right, so I'm going to right click and create my own material. So right click, create a folder called materials. The reason I'm making a folder first is it's always a good habit to make a very clear folder structure in Unity, because your project will become bigger and bigger and bigger. Okay, right click and create a material inside here. And I'm going to say maybe transparent. Maybe I will make a blue transparent material. Maybe it doesn't matter how what you name it, but it's easier for me to understand. I probably will name in the future, maybe blue matte, blue shiny, red transparent, and so on. Yeah, so it's just however you want to name your material. And this in the inspector, you can change the properties, and I'm going to first apply this material to my cube. So if I don't do that, I just create the material and I can change the color. Maybe I just change the color to blue, yeah. But it doesn't apply to this geometry. So now I can just drag this material to this object like that. And I can make this transparent, but your shader should be allowing a transparency. So we should change this to transparent. It's not transparent. You have to make the surface color to have opacity. So I'm going to make it a little bit very opaque, very transparent. Yeah. And I'm going to change the color a little bit. Yeah. I'm going to turn this off later. This is just to show us what where the flocking population got generated. Okay, so now we know that there is 0, 0, 0 position here. This is 10 by 10 by 10 box. Okay, and it warns me that I have to save. I'm gonna save it, Control S. All right, now I'm ready. I'm going to right click, create an empty object. I'm going to name this one called Boids. And I'm going to set the, it's an empty object. There's no property whatsoever. I'm going to set this to 0, 0, 0 position. And this is a normal ways of running a script which doesn't have to associate with any kind of geometry or object. Okay. So now we go to the Boids script folder. You can click on the Boids and you see there are Boids agent, Boids system, and you don't have to worry, but they have to be there. But we will only use Boids script. So you see, we just made a corresponding name. It doesn't have to be honest. You can change, you don't have to have same name. But it's a good habit. It's easier to track back later. So I'm going to drag this script and you can just drag it here or drag it to here to add the script, to associate the script to this geometry, to this object, game object. Yeah, so by default, this script allows you to change a lot of different things, and which is great because you have a lot of control. So I'm going to just explain you how you can use this. So the first thing you want to do is to add a prefab. So whatever geometry that you want to populate, all right? So let's do that. You can actually, I'm going to maybe say right click, create a capsule, for example. capsule is like a capsule-like object. I'm going to reset the position, and I can use this one as my object, for example, to start with. You can, of course, change the scale and everything. I'm going to go back to my Boids script and drag my capsule object to agent prefab. And actually, that's it. That's it in order to create a flocking behavior. Yeah, so you can actually, you just populated a lot of geometries. So which is really simple and easy. And let me explain you what are these parameters. What does it mean? So you can see that so there is attractors and repellents. I'm going to explain this later. You have this agent count, which means how many agents do you want to populate? So if you say, I want to populate only 10, I play now, this is going to populate only 10. So that's the amount of the geometries. And you can see that there's setup values, and here you have runtime values. So the runtime values are a bit more interesting. You can actually change the parameters when the script is running while it's in play. But all of these other parameters, you can only change it when the game is closed. If you change any of these values, actually including this, any of these values changed during the play, during runtime, after you close it, it goes back to, it doesn't save the parameters. It goes back to the default parameters set here. Not default, the parameters you set currently. So you always have to, if you want to save some parameters that you liked while you play, you need to write them down and then stop the game and run it, apply those parameters back. So I'm going to turn off the grid just so it looks better. And I'm going to boost this back to maybe 300 for now. And this, we remember we made the world of 10 by 10 by 10. I'm going to, you can change this size of the world. And you can also, that also depending on the size of your geometry. So there are lots of relationship between the amount of the size of the world and size of your geometry and the behavior and so on. So you need to like test it personally to get a best outcome. So for now, I'm going to just turn off this Boolean play button. So turn this off. This is a pause button similar to the pause button here. But if I turn this off, it doesn't immediately start the update. So if I play this now it stopped, right? I just wanted to make sure that it doesn't run until I explain something. But if you click on it, start running, and you can pause it. After that, it's similar to, you can just start running and pause the entire game with this pausing button as well. All right. So one thing you see that here, you have different sizes, right? So you have this size and this size. So that is determined here. So if you click if you have turned on the random scale, it means I'm going to randomize the scale. So if I don't tick this, if I run this again, so you see, it came back. So I have to turn off the game and then apply the parameter. So I'm gonna say randomizing scale is false. Then when I play it, it has all same geometry. And if I start play, they still play in the same way. The scale themselves doesn't really affect their behavior though. Yeah. Okay, but if I allow them to randomize, for example, if I wanna change the scale. So if I say minimum is 1, maximum is 1, it means it's gonna scale from 1 to 1. So there's no difference in scale. If you wanna say, okay, I wanna have like very little range difference, maybe 1.2 to 1. So very difficult to tell. So let's boost this a little bit up. So 0.5 to 1.2. Oh, it didn't do anything because I didn't make this one true. So it was not randomizing at all. So if you want to randomize them according to your value, you have to tick this true. So randomize a value, and it's gonna use my value, minimum scale, maximum scale. Yeah. So this, each of them got a value, random value between 0.5 to 1.2. So maybe if you want to differentiate that a lot more, maybe let's try this value, for example. Then it has a lot of different geometries. Yeah, cool. So that is one thing. And what is this random seed? So whenever we generate something, for example, it's same as behavior as well. So now we generated this, okay? I'm going to, just in case, Control C and close the game and Control V. It actually gets the geometry. So I'm going to move this here. I'm going to turn the script off for this guy. Okay, and let's compare. So if I run another one now, okay, so even if I have same value, because it's using a randomization, so every time it runs different values. It's same for behavior as well. It's gonna run to different directions every time, but with same parameters. So let me just move this to check. Yeah, it doesn't overlap, isn't it? Right? But this random seed can actually help you to control that. So even if they are random, but every time it uses same random seed, so it runs exactly the same random geometries. So if I want to do that, if I want to control that, I can click on the random seed, and here you should use any integer number. It can be like that kind of number. I think I'm gonna try maybe a random number like that. And then I'm going to run this. It can be like 0, 1, 2, 3. It's okay. And now this time I'm going to Control C, close again, Control V. And I move it here and I'm going to run this again. I want you to compare. This is exactly the same geometry. If you don't believe me, I can move this. Oops. Okay. Oh, I see. I didn't stop this. Okay, let me play this again. So because I copied it, it copied the script and it's running twice. So make sure you turn this off. And then I'm going to run this again. And I'm going to put this back. See, it synchronizes. It's exactly the same set of geometries. This doesn't match. So yeah, that's the random seed. It's quite handy for making some documentation or sometimes like track your geometries or generative process, because sometimes they create nice result, but it's very difficult to track back. Okay, so we have covered agent count and the world width, height, depth, and the random seed and random scale. Okay. One thing I didn't cover is three-axis scale. So if you turn this on, you will see that this value is applied randomly to scale all three axes, X, Y, Z axes differently. So the resulting geometry will look like oh, I was doing on this one, sorry. So if you use this, if you tick this one, you see that the X, Y, Z values are all randomly applied. So sometimes if you need that kind of result, you can tick this on. And what is this Boolean 3D? So if you don't say three-dimensional flocking, it creates a two-dimensional geometry on the world height position. So if you want to generate them on 0, 0, 0 position, change the world height. Oh, not height, it's depth. Sorry, depth. Yeah, so you need to change the depth into 0. So you can change this, that's two-dimensional flocking. So if you start playing, they actually do flocking, but in two-dimensional planar geometry. So if you need that, it's also quite handy. Okay. So that's 3D. In this example, we are making a 3D geometry. So we use that. Okay, so what if you wanna change this prefab to something that you imported? So for example, I'm going to use a random OBJ geometry. So I have a geometry looking like this. Let me open this up in Rhino. Okay, I'm going to open this geometry up here. So I have a geometry like this. It's random. It can be anything. You can have like material applied from Rhino or Maya. Yeah, however you want. And I'm going to export this as an OBJ. So if you have, so let's export this. File, export as an OBJ file, sample. So if you export as OBJ or FBX, they all work well. It comes, FBX will come naturally with material, OBJ will come with a material file. So I'm going to right click and create a folder called models. You want to put all the imported models in a models folder and drag both OBJ file and MTL material file together. Drag these two together to this models folder. All right, now you are safe. Your geometry is set. So if you drag this here, you will see that, okay. And we reset this to that position. Okay, so you can see that this this human model is scaled to correct position in meter unit. So 1 unit in Unity is 1 meter. Okay, so we can see that, okay, so this geometry possesses a 000, a very clean transform data, which is great. But you can see that the geometry itself is under this. So under here, you have material information, you have this geometry information. Okay, so this is this I have to cover that concept of prefab in Unity. So what does that mean is, for example, if I have a geometry that looks like this. For example, I think maybe this is your character, for example, yeah. So you have a few geometries in, maybe I'm gonna just as to become a good example, I'm gonna also for example, if this is a geometry that you want, yeah, but you already see that this is few geometries already. This will be very difficult if this is just a separated object to be populated, yeah. So if you want to make this a lot of different geometries into one prefab, so including this capsule, so all these 4 geometries are one thing. What best you would want to do is you make an empty object that has a clean transform information and name this as a my prefab, whatever you want to name it, and child everything underneath here. And you can use this freely as a prefab geometry. Prefab meaning is more like a block in Rhino, or so you can actually make some changes. So so basically you can watch this. So basically this one the color here, you can see the text color is white. If I copy this like this, and if I make any changes to this guy, for example, if I want to change the color of this guy, oh, yeah, it doesn't apply to others, right? But if I make one of these into a prefab, so in order to make this into prefab, right click, create a folder, let's say prefabs, double click and drag. I'm gonna drag this parent geometry under here, and this became blue now, right? So this is blue. I'm going to copy this. Copy is Control D, Control D, Control D. Okay, now if I go inside this prefab by clicking on this or double click on here, clicking on this arrow, and I can now, so the view here is a bit weird, but I can maybe, let's say I'm gonna make a material, right click, create a material, and I say pink, doesn't matter. And I'm gonna make a pinky human, drag this, yeah, and go back. And that change applied to all the prefabs. So if you already know that some certain things are going to be applied together, then try to make them into prefab. So this is handy if you are manually copying something. But one thing is, after you instantiate everything in script, that kind of prefab property is gone. So what I mean by that is, for example, so now if I'm going to use the prefab, instead of the capsule, I'm going to use my human prefab. Okay, one thing I didn't do is I have to have the human prefab in 0, 0, 0 position. Yeah. And I have to make sure that when it does that, these geometries are also in 0, 0, 0 position. So let me have a look. So this is not a great prefab because this is far from the 0, 0, 0 position. So normally you should be, oh yeah, I turned off the grid, yeah. So you have to move all of this next to 0, 0. So in my case, because I think they are human, they should be above ground. So I put it down like that. This will all apply to all the human geometries. Okay. Now if I change the Boids prefab to this, my prefab, they create something like that. Okay, start play. Okay, and as I said, after after they are getting instantiated in script, you cannot change the properties of prefabs. Okay. So anyways, this was an example that I wanted to show you how to create a prefab and what it means and what's the relationship between the prefab parent position transform and the child in geometry transform. But this was a very ugly example. So I'm going to make a prefab out of this geometry that I just imported from outside Rhino. And this actually is already in a very good position, so we don't have to do anything. But in case if your geometry is like somewhere far, you can always make this under empty geometry, empty game object, and position it very well according to the 000 position, because the instantiation will happen from the 000 position upwards. All right. Okay. And the geometry. So one thing is that, okay, we can just use this, but one thing I want to say is, you know, they are actually snapping to the velocity direction when they're moving. So that direction is pointing to Z direction. So if you want them to, like, for example, if you have fish face is pointing to the direction they're going, isn't it? So if you want to have that good relationship, you have to point the head to the Z direction. Yeah, maybe for the human, it doesn't make too much sense, but if you think about a fish or bird, it makes more sense. So in order to do that, because now the human is pointing Y up, which is not great for this simulation. So that's why we need to make this into a correct prefab. So if for that, because we already have this, I can actually unpack the prefab. So only thing I need is this guy, right? This is the human. I can delete the parent. I'm going to make a new parent of this guy. But before that, I'm going to position this correctly by rotating this 90° and position it. Maybe I'm going to center the body to 000. You can see that this is the 000 of the world. Yeah. Okay, sounds good. And I'm going to right click, say create an empty object, reset to 00. And this is human prefab. And I'm going to child this geometry under. So now this one, this guy's head is pointing to Z direction of the parent. So which is great. I'm going to drag this in order to make this into a prefab. Drag this into the folder. Awesome. Now actually I can delete it. I don't need it in the scene because I have it in the folder. For now, I don't need this to. I'm going to play. There, I didn't assign any prefab. So I have to drag the human prefab to the agent prefab. And they are now 2D. So I'm going to turn. Oh, they're 3D, but the world depth is 0. Okay. And turn. Start the play. Okay, so in case of human, for example, look, the 3-axis scale doesn't work, right? So I'm going to turn off the 3-axis scale and do this again. If I had the fish model or something, it would have been much better to explain this exercise. Yeah, so these are some parameters you can freely, and you can imagine now, because if they were not pointing to Z, the behavior would have been looking very weird. Do you agree with me? So now the head is actually going to the direction of the movement. So that's more natural. Okay. So you can see that the script is somehow scripted, so they are not going to go too much beyond the originally generated bounding box, but they always kind of come back. Yeah, because they have some kind of forces. Okay, so you know how to use the play button. So these parameters are now quite useful, like it's very interesting, and I want all of you to really explore that. So what are these parameters? So let's turn this cube off. Okay, so in this, you can actually change these parameters while we are running the script. All right, so the time step is about the speed. So I think they're a little bit fast. So I'm going to, if you, okay, they were messed up. So if you just make this in a little bit smaller, they will become slower. If they are higher, they will be faster. Okay. Start play. Okay. And what is the neighbor radius? So neighbor radius is, so 3 meaning 3 meter, 3 units, right? So each person here, they have to calculate their behavior according to where they are positioned based on their neighbors. So what they're doing is, I'm gonna, okay. So what, for example, for this guy's point of view, what he's calculating is he considers like from around him 3 meter radius. So he maybe within this radius, there will be around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, around like 20 people that it determines his behavior, right? The reason we have that is if we, that you don't have to count everybody, right? That will make your computer really slow, right? That's why you want to give a good amount of number that he can see and calculate, but you don't have to calculate everybody too big in order to slow your computer down. So that is one parameter. And what is the separation distance? So if when we Googled what's Boids, you can see that there are 3 different rules applied to this flocking behavior. One is separation, and we just introduced the neighbor radius, right? So within this radius, if they're too close to me, for example, in this COVID, we have to have 6 feet distance between each other, right? So that radius is something that how much you want to avoid your neighbor, but within the reached neighbor radius. So that's why the separation distance should be always smaller than the neighbor radius. All right. So within the 3 meter radius, I do search and I try to avoid people who are close to me within 2 meter. Does it make sense? Yeah. And all of these others are just the strengths of these vectors or the forces. So the flocking behavior is a combination of these three behavioral tendency. So first thing is that each of these birds or one person in the crowd, they don't want to clash with people. And they always want to have some kind of distance with people. So that's the separation. And alignment, for example, in the case of flock, alignment is a tendency that myself wanna keep the general directionality of the bigger group. So if the alignment strength is strong, it means everybody will end up going to same direction. Yeah. And you will see how it affects. And the collision is, there is this tendency of the group that they always want to go to a bigger group, or they don't want to be too lonely. Although they want to be separate, they want to have separation, which meaning they don't want to clash with somebody that is too close to me. But there's also a tendency that I don't want to be alone. That's why it end up there, they create clusters of flocks or birds, fish flocks, and everything. So yeah, if you also think about, like, if you have a lot of people, maybe, yeah, you are curious and it's a bit attractive, and you probably will have a tendency to try to go there. So these are the three different behaviors, and you can actually change these parameters around to like test how this affects your global behavior. And the attraction strength and repeller strength, I'm going to have to explain you later together with these two parameters. This is a pairing. These two inputs are optional. Right now they are 0. So I'm going to explain you this later. And you have a time step. I just explained it. It's basically, it affects the scale, affects the speed. Okay, and all of these are optional, so I'm not going to explain yet. So the most important is this these parameters that you try. Okay, so if I pause now, okay, so they are now doing quite interesting work. And if I boost the strength of separation, you see that they're all trying to separate, and each of them will be more strongly keep the 2-meter distance. If this strength doesn't mean the distance between them, it's just it has to pair with the separation distance. So if the separation distance is not, strength is not that strong, although they want to keep 2-meter distance between them, but they're also, because there are so many other factors affecting them, they may not keep that distance too strongly. And one thing you need to understand is that distance is from the center point of the geometry to center point of the geometry. But that's why some geometries now are clashing, because they're big. Yeah, I also told you the scale of the object doesn't affect the behavior. So the scale of their individual scale have been ignored in this behavior. So you just have to think about that distance is virtual distance from their center to center. Okay, and yeah, so let's have a look at the cohesion. So in order to maybe see this better, maybe let's restart the behavior. Okay. Okay, so now starting by they separate first, yeah. And if the cohesion strength is really high, they will tend to group a lot. So they create clusters much more strongly. And you can have also a negative force. Don't make negative. Yeah, that's not that against the flocking behavior, but yeah, still you can try and work with it. Yeah. But separation, cohesion, strength. So all of this can be around 0 to something like 5. Yeah. So according to how much distance your setup is. And alignment is also quite helpful because sometimes you see that now they're all going to same direction basically. Sometimes if they're like too split, too separate, then you might wanna boost this direction up or force this up. But now I think they're a little bit too much. So if they go minus, obviously they don't want to align. So the tendency here is that they're not going to align. So yeah, abusing the flocking behavior can be also interesting. Now they start to align, isn't it? Okay. All right, so that is pretty much it. And if you play with these parameters and if you are happy with some result, let's say, okay, now you can like, maybe I'm gonna let them run a little bit more. Okay, and I'm going to pause it. And in order to export this to Maya or Rhino or ZBrush, you need to select the entire object and Control C and stop the game and Control V. All right. And now we can use a plugin from the SS store called OBJ Exporter. So let's use it. So if you go to your SS store, in 2020, you don't have the SS store here, but it's gonna give you a link. So you can open the SS store from browser and log in to your account. And it's the same thing. You can see exactly the same thing in the browser. And I'm going to search OBJ export. And you will see this thing, Scene OBJ Exporter free. It's a free package. Go in there and follow the instruction to import it to your Unity package. So import it. So just import everything. Okay. And now what you will see is you will see in the file, you'll see a menu called Export and Wavefront OBJ. So that's something quite handy and great. But in order to export, you need to select all of these, right? But if you select this, do you remember this parent doesn't have actual geometry? So it's just a parent and the OBJ exporter doesn't like it. Yeah, it's a bit weird. So if you select this one from here, for example, it seems like you imported, you selected, but they are still a parent of geometry. So they don't have geometry information. So I know it's a bit weird, but you have to select this guy the most underlining thing that has the mesh file. So the easiest way to do it is just drag it from the scene. So if you drag everything from the scene, it automatically only selects those things, but it also selected my camera. So I can deselect by control select. Yeah. Okay, I have all the geometry selected. Go to File, Export, Wavefront, OBJ, and only selected object. Always tick this because otherwise it's going to try to export everything else and it's gonna error. And say export. Going to save it here. Test export OBJ. Save. Let's wait for a while. Okay. And you have this new file, OBJ and MTL exported. So I'm going to just import this in my Rhino. I'm going to open a new file. Just drag this open. All right. I think the material got a little bit, became a bit different, but we can always change it. Yeah. So if your original geometry had material, it should have that kind of material patches as well. Maybe they will come a little bit differently, but you will have, if you had like 3 different materials, there will be 3 different materials. So please, when you have time, if you are interested in this method, please try it and try to get something interesting out of it. Yeah. And I'm going to pause this video, and in part 2, I'm going to continue explain the extra options, the remaining options that we didn't explore.